Hey all, so in this video I'll be going over the 2023 Physics NHT multiple choice question. So without further ado, let us get started. So which one of the following diagrams best represents the magnetic field between two magnets? Well, just by looking at it, option A can't be it because it has to go from north to south, not south to north. Option B cannot be right either because like charges repel, they do not attract. Option C, yes, it looks correct. Okay, option D, yep, that can't be it either because again, for the same reason as I rejected option A, it has to go from north to south, not south to north, so D can't be it, so option C is going to be our answer for this over here. Okay, question number 2. Consider the diagram below, which shows a stationary object with field lines that extend outwards from the object. Okay, the field shown is most likely to be identified as an example of okay, it can't be gravitational because gravitational is usually pulling everything in, so it cannot be gravitational. Option C and D are gone, and the remaining one, electric field, is uniform, electric field that is non-uniform. Very well, a simple example can be taken here. Let's say if there is an object here and if there is an object here, which one would face more attraction or maybe repulsion, whatever, depending on the polarity? Obviously, it's going to be this one, right? Why? Because it's closer. It's closer to the center, right? So of course it's going to be non-uniform, right? So that's going to be option B. Okay, two satellites S1 and S2, each of mass m, are placed into the circular orbits around the Earth. Satellite S1 has an orbital radius of 5r and satellite 2 has an orbital radius of r. Which of the following best gives the value of gravitational force exerted on satellite by Earth? Okay. So for satellite number 1, we have GMM on r squared. Okay. And the thing is, G is constant, the big M is also constant, and M is also constant. So the only thing that actually changes is going to be the R value. Okay. So what I'm going to do, I'm going to say GMM on GMN on 5r squared, because that is the radius, okay, divided by the force for satellite 2, which is GMM on r squared again. GM, like both of the M are constant, the only thing that's changing is the R, and this time it's going to be just R and not 5r or 4r, because the orbital radius for S2 is just going to be r as denoted in the question. Okay, now let us divide this. So GMM on 25r squared times by r squared on GMM. That and that cancels out. That and that cancels out, leaving us with 1 on 25. So our answer is going to be A for this one. Okay. Question number 4. Which one of the following statements about the polarization waves is correct? Transverse wave can be polarized. Yes, this is right. Most likely answer is going to be A. Longitudinal waves can be polarized. No. Both longitudinals. No. Okay. Our answer is going to be A for this one. Okay. Because only transverse waves can be polarized. Okay. Alright. So question number 5. The diagram below shows an ideal transformer in which the primary coil is connected to a battery and a switch, and ammeter is connected to the secondary coil. When the switch is closed, the pointer on ammeter momentarily deflects. How could the deflection on ammeter be made larger? Okay, so that means how can we increase the current, essentially, is what they're asking. So we know the relationship between the current and the number of loops, or maybe the coil. So I2 over I1 is equals to N1 on N2. Okay, now I1 and N1 going to be constant. We're only changing we're only going to be focusing on N2. So N2 is inversely proportional to I2. So if we want to increase the current in the ammeter, we have to decrease the number of secondary coils. So answer is going to be B for this one. Okay. An RMS current of 15.6 amps is equivalent to a peak-to-peak current of. Okay, so I of RMS is equals to 1 on square root of I peak, right? And what we are finding is I peak to peak. So we have to first find I peak and then times it by 2 to get I peak to peak. So I peak is equals to square root of 2 times by I RMS. Okay, so square root of 2 times 15.6. And that is going to give us, let me just grab my calculator. So I'll get 2 times by 15.6, which is going to be 22.06. And we are looking for peak to peak, so we have to multiply that by 2. Okay, so 22.06 times by 2, which is equals to 44.1234. Wow, okay. But yeah, 44.1 is going to be our answer for this one. Okay. Question 7. Electrical generators may use slip ring or split ring commutators when generating electricity. When operating at equal frequencies, the output voltage of these two types of generators can be displayed together on an oscilloscope screen. The output of the split ring commutator is displayed as a dotted line. The output of the slip rings is displayed as a solid line. Which one of the best represents the two outputs? Okay, it can't be option A, B, or D. It has to be option C, because if either one of them is oscillating, so let's say for example if this is oscillating, it will be like this. Okay, that is going to be the commutator. Okay, and of course this is not right, that can't be true. And if this is oscillating, this also have to have some sort of wave, right? So correct option is going to be option C for this one. Okay, Saturn has 83 moons. One of them, I'm not gonna try to pronounce it, maybe I'm gonna do it wrong, has a mass of this and circular orbit of radius this. The mass of Saturn is this. Which one of the following is closest to the gravitational force of attraction between this and the Saturn? Okay, so again, we are finding the gravitational force, so we can just use the formula F is equals to gmm on r squared. Okay, so our G is going to be 6.67 times 10 to the negative 11. Let me just confirm that real quick. Yes, okay, cool. Times by 5.68 times 10 to the 26. And then times it by the mass of the moon itself, so 1.08 times 10 to the 20. And divided by the radius, which is given to be 2.38 times 10 to the 8 squared. All right, let me put that in the calculator and see what we get. So bracket 6.67 times 10 to the negative 11 times by 5.68 times 10 to the 26 times by 1.08 times 10 to the 20 and 2.38 times 10 to the 8, and then we have to square that. Okay, so we get an answer of 7.22 times 10 to the 19. Yeah, so closest to option D over here. Okay. Okay, use the following information to answer questions 9 and 10. All right, wonderful. So the diagram shows two stationary trolleys on smooth surface with an ideal spring compressed between them. Trolley A has a mass of 1 kilogram, B has a mass of 2.5 kilograms. The spring is released and the trolleys move off in opposite direction. The spring falls straight down. In the first experiment, trolley A moves to the left. Okay, which of the following is closest to the speed of trolley B? So this is a conservation of momentum question. All right, so we are basically saying that the momentum of trolley A is equals to momentum of trolley B. Okay, so trolley A has a mass of 1 and trolley A moves to the left by the speed of this. Okay, and trolley B has a mass of 2.5 and we have to find the velocity it moves. Okay, so velocity is going to be 0.8 on 2.5. So let's do this. So 0.8 divided by 2.5. So I get 0.32. 0.32. So answer is going to be option A for this. The experiment is repeated with a different spring. The spring is compressed 2.8 centimeters and released. Now trolley A moves to the left at 1 meters per second and B moves to the right at 0.4 meters per second. Which one of the following is closest to the spring constant of this spring? Okay, very well. So first, I guess we have to calculate the energy because we are given the compression and we have to find the value of K. So if we can figure out how much energy was utilized, we have to make it equal to the spring potential energy and then solve for the value of K. So total energy is going to be half times the mass of trolley 1 times the speed of trolley 1 that it moves at, so 1 squared, plus half times the mass of trolley 2, which is 2.5, times the speed squared. So let's do this on our calculator. So this will just give us 0.5 plus 1 on 2 times 2.5 times 0.4 squared. I get 0.2. So that is going to be 0.7 joules. Okay, now we can say that this energy over here is the same as half times kx squared, which is the spring potential energy, that is going to be equals to 0.7. We know that the spring was compressed 2.8 centimeters, which is going to be 2.8 divided by 100. So it will be, actually let me make k the subject first, would be easier that way. So we'll have kx squared equals to 1.4, and then we are finding k, so k is equals to 1.4 divided by x squared. So 1.4 divided by compression in meters is going to be 0.028 squared. So 1.4 divided by 0.028 squared, we get 1785.71 Newton per meter. Okay, the closest one based on our calculations is going to be option C for this. Okay. Yeah. So which one of the following best describes a hypothesis? Very well. So an explanation that is correct, definitely not. A statement that is widely accepted by physicists, no. An explanation that has been supported by experimental evidence, no, not quite. A possible explanation that needs to be tested by experimental evidence, correct. Okay, so this is just an experimental based questions. All right, question number 12. Sophia is moving the end of Slinky spring up and down, creating a transverse wave. Which of the lines labeled with arrows best represents the amplitude of the wave? Can't be option C, can't be option B. Yeah, option D is not it either. It's going to be option A for this one. Option A. So this is the amplitude. Okay? Yeah, I don't know. The handwriting just got a bit worse. Okay. Array of monochromatic laser light travels from air straight through a glass of block of refractive index 1.5 as shown below. Which one of the following best describes what happens to the speed, the wavelength, and the frequency of the light ray when it is traveling through the glass block compared to when it is traveling through air? Okay, so the speed is definitely going to decrease. Why? Because n is equals to c on v. C is going to be constant. So we can say n is inversely proportional to v. Now as n increases, which is the refractive index, the speed is going to decrease. So therefore, if it's going from air to the glass block, speed is going to decrease. We can cancel out option D right away. Now let's move on to the next criteria, which is wavelength. So we know that V is equals to F lambda, right? And since the source of the light is, well, it doesn't have any explicit mention of the source of the light, so I'm going to assume that frequency stays the same as well. So V is going to be proportional to wavelength. So as we figured out that if the refractive index increases, so as it goes to the glass block, the speed is going to decrease. And if speed is proportional to wavelength is also going to be decreased, right? That means we can rule out option C and option A, leaving us with option B, and frequency stays the same as I discussed earlier. Okay? Hopefully this made sense. So moving on to the next question. All right, a standing wave is produced on a flexible string as shown in the diagram below. The diagram shows the wave at two different times. The solid line represents what wave looks like at a particular time, and the dotted line represents what the wave looks like exactly half cycle later. Which of the following is closest to the wavelength of the standing waves? Okay, so we have our string of 5 meters. Okay, and let's see how many wavelengths we got here. So we have, that is one wavelength, that is the second wavelength, and that is 2.5, so half the wavelength. So we have 5 meter string with 2.5 wavelengths. Okay, so if we just divide that, so 5 on 2.5, we get 2 wavelengths to cover that, right? Okay, well, 2 meters, sorry. No, what am I doing? 2 meters. Okay, hopefully that made sense. There's also a formula that you can use to calculate this. Let me just quickly bring that up. Yeah, so the formula is going to be wavelength is equals to 2L on N. You can also use that. And, well, the L is just going to be 5 meters over here. And N is going to be this over here, like 1, 2, 3, 4, 5, like these, okay? We also use this formula over here. So using this formula, we know that our length is 5. We have 5 of the, what is it? Can't remember the word on top of my head, but I just showed that 1, 2, 3, so on and so forth. So we have 5 of this. Cancel, we still get 2 meters, okay? So no matter what you choose to use, you get the same answer, okay? So yeah. Okay, moving on. So question 15, violet light shines on a metal surface and electrons are emitted. The maximum kinetic energy of electrons emitted is measured to be 0.12 eV. This energy, when expressed in joules, is closest to. So this is just a conversion question. So we just have to multiply this by 1.6 times 10 to the negative 19. And we will get our answer. So let me just do that on my calculator. 0.12 times 1.6 times 10 to the negative 19. And that is 1.92 times 10 to the minus 20. Okay, option B. Okay, a proton of mass 1.67 times this is accelerated until its de Broglie wavelength is this. The speed of the proton is then closest to. So we know that P is equals to h on lambda, the de Broglie wavelength formula. And we can also express momentum as mv equals to h on lambda. And what are we finding? We are finding the speed. So let's make velocity the subject. So h on m lambda. Okay, now we just have to substitute the values in. So v is equals to h, 6.63 times 10 to the minus 34 divided by 1.6 times 10 to the minus 27 and 5.5 times 10 to the negative 9. Okay, and that is equals to, let me calculate that, so 6.63 times 10 to the minus 34 and 1.6 times 10 to the minus 27 times by 5 times 10 to the minus 9. I get 82.875. Okay, the closest to, okay, let me have a look if I typed everything correctly. Yeah, okay. I guess option C is going to be our answer for this question. Which one of the following light sources produces a full continuous spectrum of visible light? Yeah, incandescent globe. Okay. Okay. Light of the wavelength 300 nanometers is just able to cause the photoelectric emission of electrons from a lead surface. If light of twice this wavelength were incident on the lead surface, no photoelectron emission would occur. Okay, so the frequency, so that's saying that wavelength of 300 nanometers is just able to cause. That means the wavelength of this threshold, so this is basically like a threshold wavelength. is equals to 300 nanometers, and it corresponds to a threshold frequency. And since it's met, then photoelectric emissions are occurring. So what happens if the wavelength is twice? Very well, we know that V equals to F lambda, or maybe we can say C equals to F lambda now. So then we will have lambda, or maybe I should, lambda equals to C on F, right? So you can see that lambda is inversely proportional to frequency. So if I were to double the wavelength, if I were to double this, then my frequency would be halved. So if this is my threshold wavelength, which is corresponding to a threshold frequency, now if I were to double that, my threshold frequency will be halved. And that means no emission would occur, right? So our option is going to be A for this one. All right, some of the energy levels for an unknown atoms are shown in the diagram below. Which one of the lines labeled XeV? Okay, wait, what? Some of the energy levels for unknown atoms are shown in the diagram below, with one of the lines labeled as XeV, okay? These energy levels are not drawn to scale. A part of emission spectrum of atom shows a line at this, this, and this. The value of X is closest to. Okay. So for questions like this, I usually just recommend you do, we usually just check with the options, like which one works, okay? And what I suggest when you do that is by starting from option, like the last option, and going up, because the answer is usually from one of the options from the bottom most of the time. So what I'm gonna do is, okay, let me draw some arrows for the emission first. So that, then that, then that, that, final one, which is that. Okay, so I'm gonna try and substitute X as 8.5 and see if this is giving me the answer at all. So 10.4, oh, okay, clear. 10.4 take away 8.5, I got 1.9. okay, let's try 9.5 take away 8.5. That is going to give me 1, which is good. And I do 8.5 take away 6.9. It gives me 1.6 as well. So my answer is going to be option D here. Now, as I said, whenever you're doing a trial and error, please make sure you start from the last option going upwards, because most of the time the answer is one of the bottom ones. Okay, so that is just a quick way to, I guess, increase the speed when you're choosing check and guess method, because it can be very time consuming. Like imagine if I started from option A and going downwards, I would have to do a lot of calculations rather than just doing one. So start from option D and then go all the way to option A whenever you are doing a trial and error method. Okay. A pion or pion, okay, and its antiparticle, each at rest, annihilate and produce only 2 photons with a total energy of 4.5 times 10 to the negative 11 joules. The masses of pion and its antiparticle are the same. The rest mass of pion is closest to. Very well. We're going to be using E equals to mc squared for this one. But rather than using m, we have to use 2m c squared. Okay? Because we are finding the mass of pion. Okay? And they are the masses of pion and antiparticle are the same. So we have to use 2m. So 2m will give us the total mass of the pion and its antiparticle, and we just have to divide that by 2. So that's why I'm considering 2 times the mass. So if you want to get m, yeah, we have to use 2m, if that makes sense. Yeah. Okay. So 4.5 times 10 to the minus 11 is equals to 2 times the m times the 3 times 10 to the 8 squared. Okay, so our m is going to be 4.5 times 10 to the negative 11 on 2 times by 3 times 10 to the 8 squared, which is equals to 4.5 times 10 to the minus 11, 2 times 3 times 10 to the 8. squared. Okay, so I get 2.5 times 10 to the minus 28 kilograms. Option B. All right, yeah, so that's it for section A, the MCQs for this exam. Hopefully you found it useful, learned from this, and I'll soon be able to upload the short answers as well. So I'll see you in the next video. Till then, bye-bye.